Welcome back to another year of Advent of Code. It is, for all intents and purposes, December 1st, even though it's actually November 30th here. The first problem has opened, and that's what we're going to get into today. First, though, I want to call out Tor for submitting this wonderful PR. They did a wonderful thing and they converted one of the days in my repo into a cargo generate template that we're going to use to set up every day now. So if we look at just L, we see create day as a new command, and I'll create day one. Cargo generate on the left here has used the files in daily template on my file system, which includes a number of directories and whatnot, and created day one. So if I do just work day one part one, this should start working. And of course our tests are failing because we haven't built the tests out yet, and also our process function for day one part one doesn't even exist. So let's get into figuring out what the problem is, and then we can start building out our test. Every day there will be a word problem with a story behind it. Today is an introduction, so something is wrong with global snow production, and we've been selected to take a look. I know nothing about global snow production, so... The elves gave us a map. On it, they've used stars to mark the top 50 locations. This is just describing the puzzle on the front page. So if we go back a page, this whole area is going to be an image. That's what they're more or less describing. So collect stars by solving puzzles. Every puzzle grants 1 star. Good luck. So this is where the problem actually starts getting described. Can't use a weather machine. The elves are loading us into a trebuchet. Unfortunate. They discover the calibration document, which is our puzzle input. So if we look at this, this is our puzzle input right here, and it's been amended. The elves are having trouble reading it. Each line originally contained a calibration value that we need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. So I guess 1, 2, 3, 8, 2, 5, and 7. So 1, 2, 3, 8, 1, 1, 5. Oh, I guess there's a 1 here. And 77. So if there's only one number, it's 77. Adding them together produces 142, which is going to be our test output. What is the sum of all of the calibration values? So here's the question that we need to answer. Here's the test input that we're going to use in our test. And here's the result that we're going to need to produce. So here I'll start in part one by setting up our input here inside of test process. And if I remember correctly, this was 142. So given this input, when we run our process function on that input, we expect 142 to equal that output. Obviously, if we hard code that, in this case, I'm returning a result here, so I'll have to hard code it like this. Oh, if I don't typo. So if I hard code 142, obviously our tests pass. And this should give you the idea of what return value we're actually looking for here. I've written this so that it's a process function that takes a string slice of the input and returns a result. So it's either going to be OK with a string or an ERR with an AOC error. An AOC error is our custom error, which we haven't really built out yet because we're not even really going to use it today. So I think I'll make this test output a little smaller until we need it. And now we need to actually implement our function here. And after we do the successful implementation, I'll go back and I'll go through all of the code. So if you missed something, don't worry about it. I'll be going over this at a beginner level after we do the implementation. So let's start out by making sure our test fails so that we don't have some spurious, success that we're passing through here. And we need to get the first and last number in every string here. So to me, that says we need to iterate over these strings, and then we need to filter out the characters based on what can parse as a number. And then we need to take the first and the last of the resulting value. So we can do this via iterators. I'll get rid of this underscore so that Rust knows that we're going to use this input. And Rust has this great function called lines. Again, if I can type correctly. So we've got input.lines, and there's this wonderful function called inspect. So we can start out with input.lines, which will take this input and chop it up into each of the lines for us. We can see that that's true using .inspect on this iterator, which on the left here shows us the debug output. So we're doing dbg with the value of v, which, I should probably name line, honestly. So we're debugging out each line, and on the left-hand side, we see each line getting debugged out. So we know that we have a line at this point. Inspect is really helpful if you're in the middle of a chain of an iterator, and you're not quite sure what you've got, and you want to figure it out. Or if you want to just make sure that you're getting what you expect to get. So on lines, which gives us each of these lines, we're going to use map, which is going to give us each of these lines and allow us to turn it into something else. In this case, we're going to use .cars on these lines. So we're getting effectively string slices here, right? And this will give us each of the individual characters. So for each character, we need to find a way to turn this into a number if possible. So what we're doing here is taking line.cars, we're filter mapping with character. Character can get turned into a digit with a radix of 10. This returns us an option, which is what filter map takes. So that means this whole iterator right now has been changed into an iterator of numbers and none of the characters. We've filtered them all out at this point. We can see that if we do let it and bring up the type inlays. Type inlays are a Rust analyzer feature, which are super useful. So IT here is our iterator, an impl iterator with an item of U32. Now the way iterators work, they give us this next function. And according to our input, if we look at everything has at least one number. So we know if we've done everything correctly at this point, that this will always exist. So if we expect on that, we can unwrap it. So we get a U32 for first here. And then we can use it.last to get option U32. So this is an optional U32. It might not exist, right? So if we're at 7 here, then there's no number after it. We won't have a value. For all of the others, we'll have 2 values. So if we match on last here, and I'm going to use Rust Analyzer to fill these match arms, which it'll do automatically. So we'll get some num and do something if it's a number. If there's a number, we do first plus last. And if there's no number, we do first plus first. In this case, it's not going to be last, it's going to be num because we just unwrapped it. This match, because Rust is an expression-based language, returns these values, which are the edges of the branches effectively. And instead of collect here and instead of having string here, I'm going to change this to sum. And I'm going to say we're going to sum into a U32 using Trebuchet syntax, which will make our output a U32. We can get rid of our fake return and output OK option or OK output to string. And you can see on the left, we've got a bit of an issue here. So what I'm going to do is I'm going to take debug. I'm just going to wrap it around this entire match statement. And when I do that, it's going to take that whole expression and tell us what the values are for each line. So 3, 11, 6, and 14. And those are wrong. But those are wrong because I misread the question. So we need to concatenate these 2 values into a number. I'm adding them. So we can take a real easy way out here and use format with the 2 values, which will give us a capital S string, which we then need to parse, and we'll parse this into a U32. That will give us a result because it might fail. But we're going to do the same thing here. So format first. So let's get rid of this debug quickly. And because this match is always going to return the same thing, right? So we've got a string here that we've created, and we're trying to parse that into a U32. So that returns us a result. And we can say with expect that that should be a valid number. Of course, I've missed a comma over here. So we get a reformat jump, and then our test on the left is passing. So this is a little messy. I could probably clean it up a little bit. For example, if we took the parse here, because we will always have this string coming back, we could stick that on the end of the match. We could also take this and we can bring it in here so we can match directly on that expression. We do really need to keep this iterator separate. And okay, maybe this is a little bit verbose, but it's pretty straightforward. So now our tests are passing. Let's go back to Advent of Code. We'll grab our puzzle input. Actually, something that just happened is really important. If you go to the input for your puzzle and you see this translate page to English pop up, you do not want this to translate to English. This happens sometimes to people in Advent of Code. They hit translate here, and then their input is wrong because their browser is trying to translate it from raw text into English. So I'm going to click never translate this site here, so we're never going to see this pop up again. And then I'm going to copy my whole input and drop it into input 1. And if I cargo run bin part 1, it should compile and give me an answer, which it does. So we got 55,172. We go back over to Advent of Code, drop our input in, and we got a gold star. So we successfully answered the question. Our calculation isn't right for part 2. It looks like some of the digits are actually spelled out with letters. 1, 2, 3, 4, 5, 6, 7, 8, and 9 also count as valid digits. Equipped with this new information, you now need to find the real first and last digit on each line. So we get another input and we get another test value. So we'll take those and we'll head over to part 2, which we haven't started yet. And we'll stick that in our test. We'll take 281 and we'll stick that in assert equals here. And then the code from part 1 is mostly going to be reused. So we'll copy this and paste it in right here. I am a huge fan of duplication in Advent of Code, doing part 1 and part 2 in different files, because sometimes it requires you to damage the output of part 1 to do part 2. So in our case, the thing that we need to add to this, and this is one of the fundamental pieces of Advent of Code. You're going to get a part 1, you're going to solve it, and then part 2 is going to ask you to change it in some way. So it makes a lot of sense to do part 1 in a way that allows you to change it easily rather than being perfectly efficient. Then in part 2, you can change it and go back and optimize both of them. And I think actually what I'm going to do here is effectively cheat. So we've got this line, right? And we need to change out some of the characters in batches and groups before we can continue. So I think what I'm going to do is this. So we do line.replace 1, 1, And I'm just going to type this all out. And due to the magic of editing, we're going to have a replace for every single series of characters. This gives us a line that we can then use exactly as we wanted to before. So if we just work day 1, part 2, we get our test to pass. Now, let's make sure that our day 2 doesn't pass if we change this. Okay, here we go. Part 1 right here. I think I saw this and didn't fix it in the template. All right, so I fixed my template to run the right test. And now we have a failing test here. And if I save this, we have the wrong number. So 281 versus 211. We are expecting 281, so we're getting the wrong number. Ooh, it looks like, is 16 valid for this? 1, 2, 3, 4, 5, 6, 7, 8, and 9 also count as valid digits, but 16 does not. Is that true? All right, in this example, the calibration values are 29, 83, 83. So it's whichever one is first is the one that gets replaced. So 2 doesn't count here, or does 2 count here? I guess it doesn't matter in this case. This is one of the things also for Advent of Code that can be confusing. There's kind of like unwritten rules or unwritten information. It's unfortunate that we saw some of this in the first example. So let's set up tests, additional tests. So what I'm going to do here is use rstest, which I haven't pulled into my dependencies here yet. So rstest workspace equals true. If you didn't have this, you would do a cargo add for rstest, and you can see it compiling in on the left here. And then we'll go back to part 2. And this is copied straight out of the doc, so we need to modify it a little bit. Call this line test. We'll say line and expected, and line is going to be a string slice. And expected is going to be, I guess, the output here, right? So it'll be a U32. And then we'll call what? We basically need to take this and abstract it out into another function. This can be called process line. So fn process line. Still taking a string slice here, if I remember correctly. And we'll be returning a U32. I'll paste this code in, go back up, fix that. And then we don't need to add this here, so we can just run process line right into map like this. And now we'll be process line on not input, but line. And then these values are going to be the ones that change. So we've got these lines. How many lines are there? 1, 2, 3. Let's do it this way. Multi-cursor action in VS Code. We'll do case, this, call them all 0 for a second. Bring the rstest macro up to the top here. Get rid of these other cases. Then we need these values. And if we select all of these and hit, in my case, Command X, so for cut, I'm going to select all the zeros and I'm going to paste, and it will just paste in all of those values for us right where they need to be. And now we've got a whole bunch more tests running. So now we've got 8 tests. We've got 5 of them passing, 3 of them failing, and it looks like one of them skipped. One of them skipped should be our part 1. So here we'll focus in on the tests, I think. You can see here that I'm using cargo watch -s for a shell command, and I'm running just test part 2, but you could run cargo test or cargo next test or whatever. It looks like case 4 is failing, so that would be this one. And that would fail because of what we did before. So this is exactly what we needed to test. So we're replacing 1 first and then 2. So our little cheaty method doesn't work. So the question then becomes, how do we do this and what do we do here? It seems to really want us to do a for loop where we keep the index around and then check to see if the forward slice matches. So we can definitely do that with starts with as we go through. We aren't really iterating over any regular interval. So we kind of either need to iterate over characters and string slices, or we need to use a for loop, which I think we're going to end up using a for loop here. So my first thought here is the for loop would work, right? We could use indexes and we could do it that way. But we could also potentially use something from the iter tools crate. The first candidate that I see going down the list here is batching, which is a meta iterator adapter whose closure receives a reference to the iterator and may pick off as many elements as it likes to produce the next iterator element. I don't particularly love this approach because there's no guarantee we're going to match, so we would have to peek forward, which is easier to do with slices, I think. The other thing that I can think of doing is kind of generating this iterator from the string slice. So that would be using unfold. There's a version of unfold in the Rust standard library that might work for us. The way this works is basically we keep giving it the next item using an option type. And when we're done, we do none. And then this is just an iterator of the values that we've given it, which we can then operate on. That would generally allow us to keep most of our logic here, anything below this line. I think we could potentially use from function here from the Rust standard library, which I found just by going to standard iter looking for functions and seeing what we had around here. Just because in the past I've seen people use successors and I thought, hey, maybe there's a function in here that could help us. This creates a new iterator where each iteration calls the provided closure. In this case, there's some mutable variable. We call this function. We move that count into the function effectively, capturing it. We add 1 and then we return a value. So we could kind of move our index along inside of this function. So if we do use from function, this is what we'll end up with. On the left-hand side, you can see that 8 of our tests are now passing. And what I've done here is used from function to create a new iterator using this function. So we're kind of keeping around some mutable state. So this index is our mutable state. I decided to not use a for loop in this situation or any kind of infinite loop, which we also could have done. Because honestly, I don't get a lot of opportunities to use from function, and I felt like it was a good use case for it. So from function starts off with this closure that has move and then the arguments, which it takes none, and then the body of the function. So what's happening here is we're creating a mutable index variable starting at 0, which gets captured into this closure. So our logic all runs and index is effectively captured here. So we add 1 to it and return the result each time. The result is the character that we had before. So in this case, every time we iterate through this iterator, every time we go to choose a new value, we're taking the line starting at the new index and going to the end of the string. That becomes reduced line, which you can see is a string slice here if I bring up the type inlays. And then we have this really ugly multi-if else that I really would love to find a way to clean up. But for now it works. If reduced line, which is that string slice, starts with 1, 2, 3, 4, 5, 6, 7, 8, or 9, then we return that character. And we can actually ignore the index, I kind of figured out. But I think to have a true result here, what we would actually end up needing to do, if it mattered, which it doesn't for this example, is for each of these plus equal, let's say 3 for 1, etc. Right? So yada, yada, yada down like this. Really, the way that I would do this if I was going to do it is like this. I would take all of these string slices and I would say index plus equals that string slice dot length. So now there's no way for us to kind of mess up the amount of indices that we kind of need to move forward here. But for our example here, it actually doesn't matter if we do this because none of the inner values here end up being numbers. And if any of them overlap, which some of them do in each of the lines. So here we have 8 and 2, or I think here we have 2 and 1, and so on, right? We've got 9 and 8, which don't overlap, or we've got 1 and 8 here. It doesn't end up mattering, right? So if we have 6 here, that gets converted, and 16 isn't a valid value anyway, so it doesn't matter. Effectively, that bug in our program wouldn't have mattered for the purposes of running this program. But if we keep this index skipping and we run our tests again, we can see they all pass. So really what's happening here is we check to see if it starts with any of our magic strings. If it does, we add that number of characters to our index and we return the character that represents that string as a number. Otherwise, we just take the next character off of the reduced line, we increment by 1 to the next character, and we return that instead. Then our logic for iterating over these lines or this iterator is exactly the same. So line iterator, filter map, character to digit, didn't need to change any of that. So all's well that ends well there. And of course, our puzzle input hasn't changed, but I'll go grab it from the input anyway. We'll dump it into input 2, and I'll run the part 2 bin. That gives us 54,953, which, as always, I hope is the right answer, because we don't know until we click submit. And my answer is too high. So I wonder if some of the lines here have behavior that doesn't exist in our test cases. Because if we run all of our tests for day 1 here, all of our part 1s pass, all of our part 2s pass. Oop, I didn't mean to click it like that. All of our part 2s passed, and then our test process passes. So everything here passes, which is really unfortunate. This is something that happens in Advent of Code. You can code against the test case and you can code against the result and it can still not produce the right answer. So unfortunately, we don't have anything to go on here really. Let's just make sure that part 2 is pulling in the right input. Yep. Make sure it's using the right process function, which it is. So that is super unfortunate. So we need to kind of just figure out what went wrong here. So my first thought is that maybe there's a number in our input that kind of counts for 2 different numbers, if that makes sense. Like if there was 73, would that count? Again, all of our tests pass, so we kind of are stuck looking for something, some detail in the word problem that could give us an insight into what the actual issue is. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 9 are also valid digits. I wonder. 9, 8, 7, 8. Okay, so I took out the change that I just made for the indices because apparently that is a required feature of it working. So instead of 1, it goes character by character, and if you recognize the substring at any character, I think that counts. So let's see if we can find one that looks like that. So this is exactly when it would matter, I think. So let's take this and pull it into our test cases. So here's our test case, and we are going to have to figure this one out manually. So it's going to start with a 5 because 5 starts here. And then if we do it with the index skipping, we would end up with 2, so this would be 52. And if we did it without the index skipping, we'll end up with 1 as the last. I believe that's correct. Yeah, so testing it currently, if it's 52, then our process gives us 51. And if my guess is correct here, if this is actually the issue, then doing the index skipping should give us 52. This test will pass now because it gives us 52, but that gives us a number that is too high, as we just saw, because we stop at 2 and not 1. So this is not just the numbers in the strings, but the numbers can overlap, and both of those are valid if they do overlap, or at least the last one is valid. So in this case, we get 5, 1 is the correct answer. And if we do this index skipping, then we get the wrong answer. So we won't do the index skipping, and we'll just increment every single time by 1. And this should pass our tests, and everything's golden. So we've got 10 tests passing. We've got our test process for part 1 and part 2. And then we've got 8 of our test cases now, including, let's document this a little. This test case is from the real input. It tests 2 overlapping numbers where the second number should succeed. All right, so we are good for day 1. And if we go back to our calendar, we see both of our stars here, which is absolutely wonderful. But we are not done yet. Let's start off by running a cargo bench. And this output is sort of incredibly fast, right? Because we're not really doing that much. So this is in microseconds, if I remember my characters correctly. So this is running part 1 in, let's go with median, right? Median or mean. 92 microseconds and then 171 microseconds. That alone doesn't give us too much information about like the speed of this program. So if we run dhat, we get some interesting output for part 1, about 9,000 bytes allocated at t, gmax, and t end. We'll go over these at some point when it matters. I'm just looking for some casual numbers right now. And it's the same for both, so we're not doing a ton of allocation. This is post-edit Chris back again. I refactored it a little bit after realizing what we realized when we did part 2. So instead of having the from function, instead I iterated from 0 to the line length, and I put the filter map on that, and then just continuously fed in a shorter and shorter line. All the other logic is still the same. Everything's just merged into this one function here, and we are no longer using from function. We're using an iterator over a range from 0 to the line length, which gives us effectively a slice of an ever decreasing look into that string slice. So this is very much better, I think. The from function was fun, but it was not the simplest approach in either of them. That is largely different. So for us, it's time to go over this from a beginner's perspective, from a first-time Rust user. So if we take a look at part 1, what we end up with is a function that accepts a string slice and returns a result. It's a result from the Miette crate, but you can think of this as the standard library's result as well. If we get the result that we want, we're going to return an OK string. Or if we don't get the result we want, we're going to return an AOC error. In this case, today, we didn't really have any error handling, so we didn't really worry about this at all. On the left-hand side, you can see result is just a regular enum. If this is your first encounter with enums are just like any other type, except they can be one of 2 different values. So either it's going to be OK with the value that we specify, so in this case it's a string, or an ERR, the value we specify, in this case it's an AOC error. That's why at the end here, we wrap our result in OK. So here we've got input, right? And we've got input, which is a string slice. In the Rust docs, if we look for str, we can go to the primitive type and we can open the sidebar. In this case, if we just scroll down enough, we will end up seeing lines here. And if we click on lines, it will take us to lines, which is an iterator over the lines of a string as string slices. This is a super useful function for advent of code specifically, but also just kind of in general, because it allows us to take our input, which is this multi-line string here, and split it on these new lines without having to type, carriage returns or new lines or whatever. So this works cross-platform. If you're newer to Rust, you may be interested to know that lines doesn't return, some iterator type. It returns something called lines with a capital L. And if you click on this, you'll find out that lines is a struct. This is a regular struct, just like anything else. And the reason we can map over it here, again, if we open the sidebar for lines, we can see that it implements iterator specifically. So there's impl iterator for lines. So we're implementing the trait iterator for the lines struct. And the iterator trait is basically like an interface if you're unfamiliar. So it provides a bunch of methods for us. The core method that is required to be implemented is next, and everything else is based off of that. So in here, we'll be able to find the map function on the iterator trait, which we can use because here we have a lines. And if I look at the type inlays for Rust Analyzer, you can see that we have a lines here. So we map over this and each line is going to be a string slice. We know this because the implementation of iterator for lines defines its item type, its associated item type, as a string slice. So line will always be a string slice. And if we call next, what we get is an option wrapping a string slice. So basically this means there could be a value next or there could be no value next. If there's no value, we get none. And if there is a value, we will get some with our string slice inside of it. This is another enum just like result. So while we're mapping over this, we have a string slice in line. And once again, if we go to the stir docs, the cars function is the exact same thing that we just did with lines. So while lines is a function that returns us an iterator over string slices, each line, cars gives us a cars struct, which is an iterator over each of the characters in the slice. And again, if we open this sidebar here, we can see that there's an iterator implementation for cars, and the item type is a car. Cars are special primitive types in Rust. They're written with a single quote. So now that we know that we have an iterator, we can go look at the provided methods for iterator. And in our case, there's a function called filter map. Now this is the same as doing a filter and then doing a map. We just did a map here to turn these lines into what will eventually be a U32. So in this case, filter map, which we can see on the left here for the function signature, takes the item for the iterator, so self item, and returns an option. What this means is that if we want to return this, if it's a value we want to keep, we have to return it wrapped in some. If it's a value we want to filter out, we return none. Because of the way this problem is set up, we need to turn these characters into digits, potentially. So if we go to car, which character is at this point, right? If I show you the type inlays again, it's a car or a char or whatever you want to say. And the 2-digit function exists on the car type. So given 2-digit and a radix, so we'll say it's base 10, right? This is our regular number counting system, base 10. And we turn this character that we have into a digit, a U32. Now you'll see that 2-digit returns an option. It just so happens that filter map also wants an option returned. So we don't have to do anything extra here. All we need to do is call 2-digit. And if it's a parsable digit, it will continue for us. It'll get stored in this iterator. And if it's not a parsable digit, we'll filter it out. This is one of the really nice things about using enums in Rust in combination with these iterators. So we're left with this iterator and we haven't consumed it yet. We haven't used all the items. So really all we've done is we've said, give us all the characters. We're going to filter some of them out, and we haven't done anything with that iterator yet. So what we have here is something that implements iterator with an item type of U32, because that's what 2-digit gives us. We make sure that we declare this as mutable because we use the next function, which comes on iterators. Remember, next is the only required method that has to be implemented for the iterator trait to be fulfilled. So we know that if this, whatever type we have here, implements iterator, then we have a next function. Our next function takes an exclusive reference, which is this ampersand mute, to the iterator itself. So that's why we need the mute here, because this next function requires that that is something that we can mutate or we have exclusive access to. The next function, as we went over before, it will either give us an option, some of the item, or none. In our case, we know that the first value is always going to work because this is advent of code. and they don't give us invalid input. So we can use expect. We go to option, again in the sidebar, there's unwrap, and there's also expect. And expect will take that value outside of this option. So it'll unwrap it for us. The only downside is if this is a none value, our program will panic and crash here. So expect allows us to give a message for, what we expect this to be. In this case, it should be a number. It should always be a number because Advent of Code has guaranteed that this will be a number for us. And that gives us the first U32 out of our line of strings or line of characters. If we go back to iterator, we also have more functions. In our case, the function that we're interested in is last. So last gives us an option of the item. So there may or may not be a last item. If the iterator is empty, if we've consumed everything by grabbing the first value, then there's nothing left and we'll get none. This is what happens in the case where we reuse first twice. So in this case, what we're doing is we're taking these digits, these U32s, right? We're checking to see if there's a first one, and then we're checking to see if there's a second one. The first one will always be there, so we expect an unwrap. The second one may not be there, so we have to check for it. We can use this match expression to match on it.last, and if it's some number, we use that number, and if it's none, then we duplicate the first number twice. And in this case, what we're doing is I'm choosing to format this, which gives us a capital S string. So if we look at this, we can see the type inlay says that what is returned from this match is a capital S string because of format. We could have taken other approaches here. This is just the one I decided to do. The question then is we have to do something to get this string back into an integer. And string in the docs has a function called parse. And parse is super general. Parse can do a whole bunch of things for us. We're not going to cover them all today, but one of the things it can do is parse a U32 from a string for us. Because it's so general, we have to specify exactly what we're expecting from this parse. So we get parse, and in this case, we're using the turbofish syntax. So this : and these two angled brackets with the type in the middle. We're saying we want to take the string that is returned from this format. We want to parse it into a U32. Now, the type signature here on the left is a little bit more complicated than the ones we've been looking at already, but effectively this returns a result where the success value is the value we want it to be, this U32, and the failure value is some error type associated with that type. So in our case, if we get rid of this expect, which will unwrap the result for us, we can see that the error that we get back from a parse for a U32 is a parse int error. Now, we always expect this to, parse well because this is Advent of Code, because this is valid input. So we can expect and unwrap that. And because Rust is an expression-based language, the last expression, note that there's no semicolon here at the end, the last expression in this map is the value that gets returned. So format gets returned from the match, which we call parse on, which we call expect on, which unwraps our value. This is our last expression, which is that U32. So that gets returned from map. So now in our bigger iterator, we have an iterator of U32s. And if we go back to the iterator docs, there's a function called sum on iterators. And this sums the elements of an iterator, which makes a lot of sense for numbers, but can be used for anything. Well, anything that implements the right traits. It has to implement the sum trait that we can see here on the left. But for us, we don't have to implement anything because, adding U32s together just works. Now, these are U32s. We also have to decide what type to add them into. For example, if you had a bunch of U8s, that could overflow and you might want to sum them all into a U16, a bigger number. We again use this turbofish syntax because sum is general like that, and we have to specify what container we want to sum these into. That gives us the output, which we then wrap in OK and return from our function. Now, part 2 gets a little bit more interesting. We're still using input.lines. This is still the same setup. We're still using map, but we've got this process line function now. And this process line function, we could set up like this, right? We could have some value here and we could call that like this, and that would work just fine. This is a closure that calls our function. It's fine. But because process line takes a string slice as its argument and returns the U32 that we're expecting, we can just pass this into map and it will apply to each of the lines in turn. That means we got to break this function out and go for each line individually to turn it into a U32. Now, we definitely did something interesting here. Instead of doing something like an iterator or a for loop or a while loop or something like that, we chose to use the from function. And this is a function from standard iter. So it's in the iterator module, but it's not on the iterator trait. What we're doing here is defining an index, a mutable index with a value of 0. Then we're using from function and a closure to basically ad hoc implement our own iterator. What happens with from function is that this function will get called every time we want a next value. So anytime that you would expect .next to be called, this function will get called. What that means is that we've captured this index inside of this function, and we can just keep using it and mutating it and using it. Now, in this case, it turned out that we didn't actually need to skip anything, as we discussed in the actual solution when we wrote it, but this would have let us skip, say, 3 indices instead of just 1 character. So we start out by defining reduced line inside of this iterator function as being a slice from index dot dot. So index starts at 0, so you can think of this as 0 dot dot right now. And what that does is it takes our string slice and it gives us a view into that string slice from a smaller or potentially smaller index. So this could be from 0 to the end. This could be from 1 to the end. And if I look at one of these lines, basically what we're doing here is we're saying this is the whole line to start with, and then we move up and we're just looking at this part, and then we're just looking at this part, and then we're just looking at this part, and so on and so forth. Now, that doesn't mutate this line at all. We're just looking at different parts of it. So that's what we call a slice, which you can see on the left here. The syntax is this open bracket, close bracket, and we always want to reference this as well because we're looking at something that exists somewhere else. We're looking at this line. With this reduced line and it continually getting smaller and smaller, we can go to the str docs and find the starts with function. So we have a string slice, right? We have this reduced line and we need to do something to check to see if the next couple characters match what we're expecting. So we use this starts with function with some pattern. In this case, the pattern is just a string, or a string slice rather. And in every case here, we are returning sum, wrapping the character that we want to transform this into. For 1 through 9, that's all the same. And then for the final character or the current character, I'm choosing to do it in a way here that does reduced line.cars.next. And if you look at the type of this, this is an option car. So there may be one next or there may not be one next. And that's important because if this is empty, right, then it won't start with anything. We'll fall through to this case. And then we take the next item in the cars iterator for this reduced line, this smaller view, this empty string that we're looking at now. And result will be none in that case if it's an empty string, which will stop our iterator. This will finish. We won't get any new values out of it. But until we get to that point, this will return sum over and over. And because we've captured this index, we can just keep incrementing that. We still have access to that new index here, just keeps going up and up. And then the rest of our code is exactly the same as part 1. So there's not really a lot to go over here. We take that iterator that we just created instead of what we did in part 1, and we still filter map it. We still use 2-digit. We still do the first and the last thing. And that's it. Again, the thing that we noticed in today's problem is that if we have a string that says 2 overlapping with, say, one that says 1, then this second value needs to also be considered a number. And this behavior wasn't specified in the question. We had to go and figure that out ourselves. So let's take a look at the leaderboard. Yes, we do have a private leaderboard. It is in the Discord channel. If you are interested, you can join. It looks like we have about 27 people as of the recording of this video. It's about 2 hours later. So we've got about 27, 28 people who have completed it within 2 hours, which is absolutely wonderful. And we can continue to look for this with the local score. In this case, somebody is looking for an internship here. And then we've got DeFellow and Greg Manning as the top 3. I am, of course, way down at the bottom of the people who have completed both days, or both parts rather, because recording videos is slow. But it's always wonderful to see people on the leaderboard. So I think today went a little bit long because of part 2. Part 2 was a little bit more involved than I expected day 1 to be, a little bit more finicky with this 2-1 kind of overlapping number situation. So I think we'll leave it at that today, and I will see you in the next video. Feel free to ask questions in the comments, anything that confused you, happy to explain it. And if you're using Rust, don't forget to join the Rust Adventure Discord, and I'll see you tomorrow for day 2. Have a great rest of your day.